In this video, we're going to demonstrate how to configure Kasm Workspaces autoscaling with the Google GCP backend. Now, we've already got our Kasm Workspaces instance stood up here, so we're going to go over to the Google Cloud Console, IAM, Service Accounts. We're going to create a service account for our Autoscale use. This account has compute admin permissions, which gives it the ability to create, destroy, and configure compute instances. If we then click and go into the settings and to keys, add key, create new key, select the JSON type and create, it will give you a JSON file to download that contains all the authentication information that you will need for Autoscale configuration. We've already got a key created here that I downloaded earlier, so we don't need to create a second one. If we then go back to VM instances, we can see our server instance here. So let's log into our Kasm instance. We go to infrastructure, pools, and create ourselves a GCP pool of the Docker agent type. And then go to Autoscale configs and create a GCP config. Again, the Docker agent type, selecting the pool that we just created, and the default deployment zone. Now, the downscale backoff is how long the Autoscale service will wait before it starts to deprovision agents that are not currently being used. We're going to set it to 60 seconds for the demo, but in a production environment, you'll want to set this higher so that agents aren't deprovisioned too quickly after a user logs off. The standby cores, GPUs, and memory are the level of resources that you want Autoscale to keep available at all times for new workspace sessions. We're just going to set it to 1 core, 0 GPUs, and 1 gig of RAM for the purposes of the demo. The overrides allow you to over-provision your agents by telling Kasm they have more resources than they actually do. We're not going to over-provision here, so we're just going to set the real values of 2 cores and 8 gig of RAM. We now need to select the Google Cloud provider. We're going to call it GCP provider. The GCP credentials is that key JSON file that we downloaded earlier. The max instances lets you set a hard cap on the number of instances that can be provisioned, regardless of other resource constraints. We're just going to set that to 3 here. The project ID we can acquire from the URL in our Google Cloud Console. The region in our case is Europe West 2, and the zone is Europe West 2C. Now, we're just using the basic E2 standard 2 machine type, but you can set whatever is suitable for your requirements. Now, the machine image can be a little bit fiddly to acquire. The easiest way to do this is to go to Storage and Images, and then you can search for the image that you want. We're going to use just a basic Ubuntu Noble image. So we're going to find that here. We're going to use the AMD 64 version. If you just copy the link and paste it into the URL address bar, you can see the name. And what we need here is everything from projects up to the name of the image. So we're going to take that and we're going to paste it in there. We're going to do a 50 gig boot volume. Now, for disk type, there are a few different options, including PDSSD if you need high performance. We're just going to do a balanced persistent disk because we don't need that performance for the demo. We're not using custom managed encryption in this environment, but if you are, you need to specify the key name here. Now, for the network and the subnetworks, very similar to the images, you can just go into the networks list, find them, copy the URL, and pull out the project ID, and then the path to the network in question. Both of ours are just on the default network. Obviously, if you're using custom networks, you need to make sure that information is correct. We're going to provide a public IP for our agents here. You can also set additional information, tags, labels, metadata, etc. None of that is mandatory, and we're not going to do it here. We're going to do a Linux OS bash script. Now, the bash script in question is just taken straight from our example on GitHub. All we've done different from the default is to uncomment the internal IP fetch for GCP. And we're going to finish. And now if we go to Docker agents, this is the built-in proxy agent. We don't need to worry about that one. But in a few moments, we should see the Autoscale start to spin up new agents for us to use. And so if we just refresh the page, we can see there is now an agent that is in a starting state. And if we go back over to GCP and go back to our VM instances, just do a refresh, we can see we have a dynamic agent that has just started. So what we need to do now is wait for that image to finish provisioning and for it to run the startup script, which will install the Kasm agent, which will allow it to report back to the management server that it's up and running and ready to accept sessions. So we'll just need to wait for that to complete. And while we're doing that, we can just get down to our workspaces and have a look. We've already got the Chrome workspace that we've provisioned. If we go into the registry, we'll just also add a Firefox instance here. Now, one thing to note is when you provision a new agent through Autoscaling, it needs to download the images of every workspace that you have available to use for users. Obviously, this can take a substantial amount of time if you have a lot of images. We're just going to limit it to these two, which should speed things up a little bit, because until the image is downloaded, users can't start a workspace session with that image on that agent. So I'm just going to go over here, and we're going to start this. As you can see, if we open another tab, Firefox is not available yet because it hasn't been downloaded. So that little red triangle will stay until the image has been downloaded on the agent. So meanwhile, here's our Chrome instance running. If we go back here and refresh, we can see we have one session running, and that's half the resources of this agent being used. So now you can see the triangle has gone from Firefox because it's finished downloading. So we can launch a Firefox session as well. If we now refresh here, we can see we have two agents and we're using the full allocation of that built-in agent. So now we just need to wait for this to finish starting and register it as available so that we can start a new session on there. If we just refresh, you can now see this is running. Last reported 15 seconds ago and is using the GCP config. And if we go back here, we can see that's our agent. So what we should now be able to do is go here, start another Chrome session, and you can see we get an error because the image hasn't been downloaded yet. So we just need to wait for that to complete. Now what you can do if you go into diagnostics and logging is you can search for Docker image and you can see it's initiated the Docker image pull. So in a moment that will then log a new message to say that the image has been downloaded successfully. So after waiting a couple of minutes, if we go back here and search for image, we can see image pulled successfully both for Chrome and down here for Firefox. So what that should mean is if we now go back to our workspaces and click on the Chrome browser, we can successfully launch a session. And if we go back to our workspaces and our agents and we refresh, we can now see that there is a session running on here and that it's using the full allocation of the CPU on that agent. Now, of course, what that will mean is now that we're using all of the resources on both agents, the Autoscale provider will now look to spin up a new agent to maintain that 1 core and 1 gig of RAM standby that we said we wanted. Indeed, as we refresh, we can see there is a new agent that is starting. And if we go back to our instances and refresh, we can see there is now a new dynamic agent that's being spun up. So again, this will follow the same process. This will boot up, it will install the Kasm agent, it will report in as available, it will switch to a running status, and will then download the images in the background and be available for new workspace sessions. Now, we don't need all of these sessions anymore, so we're just going to delete them. And close our windows. If we refresh again, we can see all the sessions have now gone from here. And what will happen now is that the Autoscale agent will wait the 60-second back-off time that we configured before it will start evaluating whether or not it still needs all of the agent resources that it has available, and if not, it will start to deprovision them. Now, in the current state, it will not deprovision this agent because this one is not yet up and running, so it doesn't count it as available resources. So once they are both available, it will then be evaluated, and because this over provides what we need, it will then deprovision one of the agents to get us back down to a single one that provides the 1 core and 1 gig of RAM that we've asked for. So we'll just give it a few minutes for it to run through that. And so we can see that both of these agents are now running, and that puts them in a valid state for Autoscale to evaluate whether or not both of them are still required, which it should not need because we have way more than the 1 core and 1 gig of RAM that we require. So if we now refresh, we can see that this agent is now in a destroying state. And if we go back to our Google Cloud Console, we can see that this instance is being stopped. And when it's shut down cleanly, Kasm Autoscale will then delete the instance from Google Cloud. It does take a little while for Google Cloud to stop instances and destroy them, so it can take a minute or two. So eventually, as we refresh, we can see that the agent is gone. And if we go back here and refresh, we can see that our agent is gone and we're back down to 1. Now that we've configured and tested the autoscaling, I'm just going to quickly run through how to deconfigure autoscaling cleanly. So the first thing we need to do is go to Tools, Autoscale Configs, edit the config, and we want to set the downscale back off to 0, 0 standby cores, 0 GPU, 0 standby memory. And what that will do is allow Kasm Autoscaling to deprovision the last autoscale agent and cleanly remove it from the environment before we go deleting any configs. So we just need to wait a moment for it to evaluate it and to follow the same process of shutting down and destroying the agent in GCP. We can see it's already in a destroying state, and if we go back to GCP and refresh, we can see the instance is being stopped. Now, once that agent has been successfully destroyed, you can go into the configuration, you can delete the provider or disable it without any risk of leaving orphaned agents lying around in your environment. So if we refresh now, we can see that we're back down to our original proxy agent, and in the GCP console, just our running Kasm server. So as I said, now we can go into Pools, we can go to Provider Configs and delete the provider. We can go to Autoscale Configs and delete the config. And finally, we can delete our agent pool, and we're back to where we started.